Here's a question that New York City has been asking itself for about 30 years. Could you actually flood-proof the entire city? Not just sandbag the subway entrances, not just raise a few seawalls, the whole thing. Harbor, coastline, tunnels, infrastructure, all of it. The engineering exists, the precedents exist. So let's take this completely seriously and find out exactly where it stops being possible. The answer is, further along than you'd think, but not all the way. But let's be specific.
First, the water. New York City's flood risk comes primarily from storm surge, the dome of water that a hurricane pushes ahead of it as it approaches land. Hurricane Sandy produced a surge of about 4.3 meters at the Battery, the southern tip of Manhattan. That's not a wave, it's a slow, relentless rise of the entire harbor, water pushed by wind pressure across hundreds of kilometers of open ocean, arriving all at once. The good news is that storm surge is predictable, directional, and relatively slow. It doesn't arrive in seconds like a tsunami. You have hours of warning. And the geography of New York Harbor actually helps. It's a mostly enclosed body of water with a limited number of entry points. The Hudson River, the East River, the Arthur Kill, the Kill Van Cool, the lower New York Bay. Block these openings and you stop the surge. The Netherlands figured this out in 1953 after a catastrophic North Sea flood killed nearly 2,000 people. They built the Delta Works, a system of dams, sluices, and storm surge barriers that now protects most of the Dutch coastline. The most impressive piece is the Maaslandkering, two floating steel arms, each longer than the Eiffel Tower, that swing shut across the Rotterdam waterway when a surge is forecast. It took 6 years to build and cost about $450 million. New York's equivalent would be a surge barrier across the lower New York Bay, roughly 10 kilometers wide, combined with smaller barriers on the East River and the Arthur Kill. The lower Bay barrier alone would be the largest movable flood barrier ever built. For comparison, the Thames barrier in London protects a much smaller opening, about 520 meters, and cost $1.6 billion in today's terms. New York's main barrier would be roughly 20 times wider. Scaling from the Thames barrier, a lower Bay barrier comes in somewhere between $15 and $30 billion. Add the East River and Arthur Kill barriers, the coastal berms, the upgraded pump stations, and the reinforced subway entrances, and the full system lands somewhere around $100 to $120 billion.
That's the harbor. Now let's talk about the subway. New York City has 245 kilometers of subway tunnels. Most of them run below sea level. Several of them run under rivers. When Sandy arrived, 58 stations flooded, and the system took weeks to recover. A surge barrier stops water from entering the harbor, but it doesn't stop water that's already inside the city from rainfall, or water that enters through the hundreds of ventilation grates, emergency exits, and maintenance hatches that connect the subway to street level. Flood-proofing the subway requires either raising every street-level opening above the design flood elevation or installing deployable flood shields at every entrance. There are approximately 472 subway stations. Each one has multiple entrances. There are over 3,000 individual openings that need flood protection. Each one requires custom engineering because the subway infrastructure beneath Manhattan was built over 120 years and nothing is standardized. The MTA has been installing flood shields at individual stations since Sandy. At current pace, full protection is estimated to take several more decades.
And then there's the problem that makes everything harder: sea level rise. Lower Manhattan has already risen, or rather the water around it has. Sea level at the Battery has risen about 30 centimeters since 1900. Current projections suggest another 30 to 60 centimeters by 2050 and potentially a meter or more by 2100 under high-emission scenarios. A surge barrier designed for today's sea level becomes undersized within decades. The design storm that the system is built to handle gets more frequent as the baseline water level rises. A 1 in 100-year flood event in 1950 is now a 1 in 25-year event. By 2050, projections suggest it becomes roughly annual. The barrier doesn't stop working, but the frequency of closures increases, which affects shipping traffic through one of the busiest ports on the East Coast. The harbor handles about $200 billion of cargo per year. Every closure costs money and causes delays. The floodproofing is fine, by the way. Surge barriers are a mature technology. The Dutch have been building them for 70 years. We've completely mastered the engineering of keeping water on one side of a gate. It's New York Harbor, the subway, the sea level, the shipping traffic, the 120 years of non-standardized infrastructure, and the question of who pays for it that keep making things complicated.